Good evening, everyone, and can I welcome you to this evening's ICOMOS-UK lecture on sustainable technologies in conservation areas, managing disaster risks. I'm delighted to welcome Zoe Almazan to present this lecture on a highly relevant topic, how we make our cities more resilient to disaster. Zoe will be showcasing her recent work in Mexico, especially how digital technologies can help us plan and manage disasters more effectively. Zoe is currently a lecturer in Kingston University, but before that she worked in the construction industry and on restoration and flood protection, and therefore has a great deal of practical experience as well as academic experience on which to address this topic. And I'm sure we will all much welcome her insights. Before I hand over to Zoe, I'd just like to run through a few housekeeping ideas. You will see them on the screen, and I'm sure you're by now all very familiar with the procedures about keeping your microphone and cameras off. After the presentation, there will be a chance to talk to Zoe through a question and answer session, and you can either raise your virtual hand or put a question in the chat. This evening's presentation is being recorded, as is the question and answer session. So, without more ado, can I now hand over to Zoe to deliver this evening's lecture. Thank you.
Thank you for the invitation and for the warm welcome. I'm going to start sharing my screen. Could you please confirm if you could see my screen?
Not yet.
No? Okay, 1 second.
Okay, we can see it now, Zoe. Thanks.
Okay, that's perfect. And you can hear my sound as well.
Correct, yes.
Oh, thank you once again. I'm very happy and grateful to be here today and to support ICOMOS-UK. I've been an active member of ICOMOS Mexico since 2012, and it's a great honor for me to now become an active member for the UK. And today I'm going to give a brief lecture. I'm going to talk about the application of sustainable technologies in conservation areas and to look specifically at managing disaster risks. I had divided today's session into 3 different sections, followed by questions and answers. So I will start with an introduction of the global impact disasters have in the existing environment, followed by a closer look on how to manage disaster risk with many case studies in Mexico. And I will end with an invitation to reduce disaster risks. So I'll begin with a brief introduction. As we all know, the world is changing rapidly, and year by year, we can see how disasters are increasing and taking over our communities. Disasters can be defined in different ways. And according to the International Federation of Red Cross and the Red Crescent Societies, disasters are serious disruptions to the functioning of a community that exceed its capacity to cope using its own resources. There is a saying that while the rich lose their homes, the disadvantaged and the poor unfortunately lose their lives. No country is immune to disasters. As we can see here on this map, every single country on our planet suffers from one sort of disaster or another. We can divide disasters into different types of hazards. The first type of hazards are the natural, which are caused by any sort of natural physical phenomenon. These can be also classified as geophysical, which are originating from solid earth, such as earthquakes, landslides, or volcanic activity. We also have hydrological, caused by movement and distribution of water, for example, floods, avalanches, and tsunamis. And we have climatological and meteorological relating to the climate, weather conditions such as droughts, fires, cyclones, tornadoes, storms, and hurricanes. However, we also have biological hazards, which are caused by living organisms, such as bacteria and viruses. The most popular one right now is coronavirus. You can also experience disease with biological hazards and insect and animal plagues. And last but not least, we have the man-made or human hazards, which are events that are caused by humans, such as emergencies, terrorism, accidents, social and political conflicts, pollution, toxic substances, and even man-made fires. Now, while hazards may be natural and inevitable, disasters are not. Disasters happens when a community is not appropriately resourced or organized to withstand the impact, and whose population is vulnerable because of poverty, exclusion, or socially disadvantaged in some way. Now, we can prevent hazards from leading to disasters. Our communities and the conservation of the existing environment must be prepared. We must focus on the reduction of risks, and our governments and local authorities should focus on becoming resilient. Now, resilience and sustainability go hand in hand. Resilience is the capacity to recover and adapt in face of disturbances, while sustainability is the capacity to preserve and strengthen systems over time using its community resources. But before I move on, I think it's important to show just a 5-minute video so you can see the impacts of disasters. And now I put together a video of the disasters that impacted the beginning of 2020 due to the fact that coronavirus became very popular in 2020. So I'm just going to share video. Please let me know if you can hear the sound.
Yes, we can hear the sound. Thank you, Zoe.
just trying to check the intensity or the speed of the wind, and I'm applying full strength to try and open this. It's a bit hard. Oh God.
The United Nations reported on the 16th of September of this year to Dr. Joeri Rogelj that data shows that we are in an alarming scenario when it comes to climate change. And 2021 is recording devastating extreme weather and climate events. Just between the 12th to the 18th of September of this year, we have experienced the most extreme natural disasters, and I'm going to read the list because it really does create an impact. We had a sandstorm in Maringa, Paraná, Brazil, a double tornado in Pontelaria, Locri, Italy, severe flooding in Zunyi, China, huge hail fell in the Primorsky territory in Russia. We had Typhoon Jansu hit the coast of Taiwan. 43,000 people were evacuated just 2 weeks ago. Typhoon Shantu hit the Philippines. There's been a big snowfall in Malargüe, Argentina, floods in Jamnagar, India, forest fires, which are still happening today between Spain, Greece, and Turkey. There's been a large hail that fell in Michigan, USA, and in Uruguay, hail as large as volleyballs. There's been a tropical storm called Nicholas in Texas, USA, flooding in France, severe flooding in Malaysia, a 6.0 magnitude earthquake in China, landslides in North Santander, Colombia, a tornado in Sakarya, Turkey, and on the 7th of September, a 7.1 magnitude earthquake in Mexico, where at least 1.6 million people were affected by this earthquake. So the big question is, how can we manage all these disasters? What can we do about it? So over the past few decades, there has been an increase in the development of creating climate resilient cities using digital technologies. At Kingston University, we currently have a research team in our Department of Civil Engineering, Surveying and Construction, where we are designing and managing disaster risks. So we are analyzing our conservation areas using 3 different scales: the digital, the urban, and the architectural, also known as the industrial scale. So I'm going to try to explain these 3 scales, starting from the macro scale, which is the digital scale. So within the digital scale, we focus on the networks of communication and supply, and the application of artificial intelligence in urban planning. So using digital technology and sustainability as the main components for governmental urban planning. Now, when we talk about artificial intelligence, automatically we talk about 3 different digital tiers, which are data analytics, machine learning, and deep learning. Data analytics is taking raw data, either in real time or historical, and it provides current insights. For example, intelligent traffic lights that collect data. Machine learning uses mathematical algorithms that look for patterns in the raw data in order to make near-term predictions and provide deeper insights about the data. An example for urban planning, we use, for example, smart roads to collect data to predict which sections will result in traffic knots or traffic jams. And deep learning is very similar to machine learning, only that it is used for a longer period of time to be able to give planners predict insights as regards the data. For example, this is how urban planning can look into the future of traffic flows during a natural disaster. So we can use several platforms. I'm very familiar with building information modeling. Building information modeling can use all this data to predict any sort of natural disaster. This is an example of some earthquake simulations I did with my research partner, Alejandro Lopez, where we use algorithms to analyze scientific data on earthquakes with real-time responses to predict how structures will respond to different earthquake magnitudes. So this church is quite particular. It's located on top of an archaeological site in Mexico. This archaeological site, which is this green hill that you see here, was actually covered by lava by this volcano that you see on this right side. It's called the volcano Popocatépetl. On the other side of this volcano lies Mexico City, the great capital of Mexico. But on this side is my hometown, the city of Cholula, from the state of Puebla, or the county of Puebla. So what's particular about this church is that it's sitting upon an archaeological site. Now, with the software, we were able to predict exactly where the structure of the church would fail. I have here some animations to demonstrate what we calculated. Just 1 minute. Here it is. So for this, we use a software called ProEngineer. With ProEngineer, we were able to elevate the structure in 3D, and then we programmed the software to simulate. We can simulate all sorts of natural disasters. In this case, we simulated a 7.0 magnitude earthquake. So as you can see in the second video, we know exactly which tower would collapse and at what speed, and all the information is here. This is part of our research paper in case you want to read it one day. We found the mathematical algorithm that predicts exactly where the structure will fail. So all of this is using artificial intelligence. Now, in 2017, Mexico City experienced an earthquake of 7.1 magnitude, in which we put our predictions into test, and unfortunately, the towers did collapse. I mean, the good news is that our software worked and the predictions were accurate, but unfortunately this happened, and we could have avoided the structure to collapse completely. There are other types of digital platforms that use artificial intelligence. Cloud to Street is becoming popular in London, which uses microsatellites to create maps and show the duration of flooding events. And we also have a new platform called One Concern that also analyzes earthquakes. It's a lot more updated and a lot more advanced than the one that I used previously, but it simulates what structures could be impacted before, during, and immediately after an earthquake. As you can see here, there are some images of how we can use microsatellites also to map out all the cracks after the event of an earthquake. And we can also identify all the damaged and destroyed buildings within the city. This is what we collected from the data. So that is the first scale that we're using. Our second scale of research is the urban scale, where we focus on preparing for disaster by designing specifically digital infrastructure. To explain this, I will show another case study very close to the church we just analyzed. For another research paper that I wrote, I focused on the communities closest to the active volcano of Popocatépetl in Mexico City. So for this, we monitored the volcanic activity for a full year using microsatellites, and we were able to map all the risk zones. We were also able to predict a local solution, creating an operational plan in the events of an emergency with the help of the local authorities. And we designed an evacuation road using sustainable technology. Now, something particular about this volcano is that it shares a chimney with a twin tornado called El Iztaccíhuatl. So if the volcano Popocatépetl erupts, it's really two volcanoes erupting in one, so it's devastating. These are just some images of the microsatellites that we took. Now, I must say that because I was doing this research with a small group of researchers, we were only able to capture data once a day. But if we had a larger team of researchers, we would be able to calculate and monitor the volcano during the day, during the afternoon, and in the evening, and every single day of the year. And if we had more data, we could have made more precise predictions. This is still an ongoing project with the local authorities of Mexico, and we're looking to use luminescent aggregates for the roads that only require 15 minutes of daylight, and it can illuminate a road for up to 24 hours. Since there is a lack of urban infrastructure in these communities, we can use the local resources to provide a solution. Also, with the local authorities, as you can see here in the color red, we mapped out the emergency evacuation road. So this would be the road that we're trying to aim to use this luminescent aggregate, so that in case there's a blackout, at least these communities surrounding the two volcanoes, which you can see now in this slide, could evacuate and go to a safer zone. Now, within our smaller scale, which is the architectural scale, or I also call it the industrial scale, in this scale, we analyze specifically structural failures, and we try to understand materials behavior. Now, I always tell my students to compare buildings to a human body. So the structure, which is part of the foundation of the building, reacts very similar to our skeleton. All the building services, such as water, drainage, electricity, and gas, are very similar to our veins and our blood circulation. And the external facade and the general envelope of a building is a bit like our skin, which is also the largest organ in our bodies. So if you can analyze buildings with this mindset, then it becomes easier to give a diagnosis with a condition survey, and also give a prognosis, which is basically a prescription of how to restore historical buildings. Now, for this scale, we are using Fournier des Alpes concept of natural hazards for design purposes, where risk is a product of probability and loss, which makes it possible to actually categorize the impacts of disasters into 3 different phases, which is before, during, and after a disaster. So taking into account the previous case study, we could divide the risk into 2 different phases. We have the pre-disaster phase, where we collected data and designed an operational plan. And then we had the post-disaster recovery phase, which focuses on the few golden hours or days right after the disaster impact. So for this, we designed temporary camps for the communities closest to the active volcano. I'm going to just zoom in. This was the best location, as you can see in color green, also due to its closeness to the 2 towns that we see here, which is San Buenavista Naltican and Santa Maria Acuexcoma. The advantage of being close to these towns is because they could provide at least rapid medical response. And we also designed temporary structures. These are light-weighted structures that could be ensembled into various shapes depending on how many people or how many families would like to share a home, a temporary home. It's easy to storage, it's light, it's made out of recycled plastic and metal, which we could find from construction sites. It's a foldable structure, like origami. It is equipped with LED lights. It has a GPS system with internet, and includes a first aid kit. It can float, and it can protect families from extreme temperatures. We also designed an individual capsule for people who respond better to crisis on their own instead of in groups. So these are different strategies that could be implemented during a crisis. But the most important part of this architectural scale, again, is building surveying and recording all the damages and creating a rapid restoration plans and urban regeneration plans so that our communities can return safely to their homes and return to some sort of normality. And the last part of my presentation is just a simple invitation. We have the International Day for Disaster Reduction on the 13th of October, created by the United Nations General Assembly. We should always involve our communities and focus on the prediction of disasters, design warning systems for our neighborhoods, create awareness with our friends and family, focus on making and designing educational campaigns, not only focus on higher education, but go to the new generations. Let's start educating our children, especially in kindergarten and primary school, about disasters. And most of all, be prepared before an impact. We should also focus our research on the critical phase and the application of operational measures, which could be the information, communication, and alert procedures, application of emergency measures, and design, again, always around the critical phase. Always focus on the worst case scenario, because once we understand the worst case scenario, then after that, everything can be properly planned. So just as a conclusion, with the usage of artificial intelligence platforms, data can be collected to identify patterns which can indicate high risk zones across the globe. And conservation areas can become resilient with proper preparations, including digital infrastructure that could save not only millions of lives, but millions of monuments and sites. I always invite communities and the local authorities and our governments. We need to think creatively and find new ways to build resilience. And we should always take advantage of the developments in science and technology that could provide promising solutions. Even though they're computers, we should use the computers for our advantage. I left also some references in case you want to read a little bit more about where I found the information. And I also put together just a small presentation. I promised ICOMOS-UK to talk about what is happening in conservation areas during the pandemic. So I just put together a few slides, but Anthea and Susan, would you please, do we have enough time to show this? Or
yeah, yes, I confirm we do.
Yes?
Yes,
okay.
we do. Thanks, Zoe.
Okay. So I took a small trip, a very small, brief trip to Mexico recently during April 2021, and I got together with some colleagues that work for ICOMOS-UK. ICOMOS Mexico. And so we were discussing how Mexico's government declared that it would be irresponsible to go into national lockdown. And therefore they implemented a traffic light system dividing its states or counties into red, amber, and green zones. As a temporary solution, as you can see in this photograph, the local authorities spread disinfectant around buildings and in public spaces. This unfortunately created lots of deterioration within the buildings, but it also creates environmental problems to the vegetation and to the animals that live among us in the cities. There was no social distance, especially in Mexico City. It's very cluttered and it's hard to obey such restrictions. When I arrived at the Mexico City airport, even though there are stickers and there are posters around, it was very hard to create actually that distance due to the scale of the buildings and also the amount of people that are living in the capital of Mexico City. The transportation systems were not canceled. And also I would like to point out that there's a lack of data due to that there are no laws or legislation that collects data as regards to the pandemic. So it makes it very difficult to identify safe areas. There was also a lack of tests and vaccination centers, but there are on some positive notes. You must wear a face mask outdoors and indoors, which is one of the main, if I compare it to Europe or to the UK, it's not an obligation to wear a face mask outside, but in Mexico it is. So this is a perfect example. We are in an archaeological site next to the ocean, next to the beach, and people and tourists are wearing a mask. This is another example of a public space in a conservation area. And again, people are outside and they're wearing a face mask. And again, this is just a general photograph. You can see here that there were lots of posters and publicities that says, be careful, you are about to enter a high risk zone. Please use antibacterial gel and conserve a healthy distance. And in general, the pandemic has been managed like an epidemic by local micro-scale traffic light system solutions. And this also gave certain regions flexibility and a positivity to continue with normal activities. If we compare it to the UK, and the UK lockdown has been applied equally across the country. So it did not matter if you were living in Kingston or in the north of London, we all went into lockdown equally. Whereas in Mexico, only certain regions went into lockdown. But again, every country has reacted different to the pandemic with the tools and the resources available to their communities. I think that's all. I hope that you've enjoyed this short presentation, and I'm happy to answer any questions. I will stop sharing my screen.